Hello and welcome to a series of events. How many billions are lost due to poor lubrication practices each year? And this is part two. So, in part one, I talked a bit about contamination, ISO codes, and we got into a bit about the JOS report and the cost and the significance of that report. So, at the end of that video, I asked, has it improved since the JOS report, since which was back in 1966? My answer to that is not enough. And as I go through this example, I'll explain why. So I'll get into a specific example of why I think we haven't improved to any great extent. So this is a typical trend report for a reducer on a mine site, and it's when you look at the trend, it's gone from the end of 2013 all the way up to today, 2025. So it's a bit hard to decipher what's going on here, because what you've got is, I'll repeat, this is OPC 4 micron. OPC is optical particle classification, so it's not your typical ISO code. It's a bit more involved than that, which I'll get into later. But it's a bit hard to decipher because you've got so many of these what are called outliers, large numbers which you get up to a particle count of a million plus, extreme contamination. So I'll explain. To make sense of this, I'm going to go previous to these large events and then after, to get an idea of what's happening. So if we go back to eliminate those extreme events, we go to 2016 back to 2013, we can see the level is around anywhere from 12,000 to 25,000. So ISO code wise, that's probably an ISO code 20, 21. So not real severe, but not ideal. You're getting into what a class is the severe level where you'd want to do something. So it would have had an impact on equipment life. And we scroll forward, I should state this reducer was changed around 2018, so that's why you're seeing those different numbers. So in 2018, the change of reducer, the company decided they would take more samples, so they went from monthly sampling to sampling every 2 weeks. That's why you're seeing more data points there. But the ISO code was significantly worse. It was anywhere, if you look at the average over a 5-6 year period, you're probably looking at anywhere from 50,000 to 100,000. You've got some low points there, but significantly worse. So why is that? Short answer is I don't know, but it's not good. You're getting into the ISO codes of 23, 24, so you're looking at from a life expectation of 30% or less. That's even after the failure. So what I want to focus on now is the iron content. This is parts per million. When you look at up to from 2014 to 2018, you had a steady increase in iron content. So it looks like they didn't change the oil for 4 years, but I'm not too sure because they didn't document maintenance in this particular program. Then after 2018, we'll scroll forward a bit. We'll look at the data. It looks like they're still doing a lot of samples every 2 weeks, but they started to do an annual oil change. That really didn't affect the wear rate, which I'll explain later. But if you look at the trend from 2014 to 2015, if you tag all these lines together, you would see probably in a range of ppm of 50 to 60 ppm for iron. So I'll say that when you look at it on this data, the ppm of iron, we're talking about submicron particles. This is an analogy I like to use as a difference between like salt and warm water. Some of it will dissolve, some of it won't. You'll end up with chunks of salt, you'll end up with dissolved salt. So that's an analogy I like to use, because when you talk about iron and then ISO count, the kind of they're difficult to visualize when we're looking at particle size. So when we get into After the failure, they took more samples and took more samples and did more oil changes. That had zero effect on the life of the equipment. So OPC gives you the opportunity to look at the shape of the wear material, the wear trends, and they're classified as cutting, sliding, fatigue, and what are called garbage, non-metal and fibers, which are usually found in some samples. So the dominant wear trend here, if you look at the triangle there, it's fatigue. This is a fatigue failure based on what the OPC trend is telling us. So to give an idea of the size of those particles, this is fatigue. If you look at the last result, it's 240 particles in a sample size, and the mean size of that is 24 micron. So you're talking about 4 micron size for ISO count, you're talking about ppm. These are a large particle size of metal, which are basically creating that wear, and its majority of it is fatigue. So the fatigue trend, when you look at it over a period of time, doesn't really change that much. You think, well, why is that? I've done an oil change. You think I would remove most of those particles. This is what I say to people. Well, people think an oil change will remove the contaminants in your oil. Well, it will remove what I call the dissolved salt, because that will flow out with the oil. But the heavier particles, as soon as you turn the reducer off or the equipment off, it just falls to the bottom. And you fill it up with clean oil, fresh oil, which may or may not be that clean. You stir the pot all up again. You haven't got rid of those particles. So you generate the particles through the wear mechanism, but you're also creating more. You've already got that wear mechanism, the wear particles, in the reducer. So you're not really achieving much by changing the oil. So some background information. These reducers sampled every 2 weeks. The oil is changed on average every year. The reducers actually fail every 8 to 9 years. The new oil isn't filtered before use. They have no precondition before they filter it. The unit isn't filtered during use. They don't have a portable filter unit where they'll use it. They use an SHC 150 synthetic lubricant, which is expensive. Synthetic oil is typically 3 to 4 times the cost of mineral oil. And the oil volume on this particular unit is about 200 litres. So the cost of basic maintenance, so the oil change and the sampling, is approximately $4,500 each year. So I'll get into it in the next series, part 3. But the question is, why are these reducers failing prematurely?